Implicit differentiation is a little different because it's a derivative that has x and y in it. There are a few things whenever we first started doing implicit that really confused all of us in calculus, and we wanted to gather up all of those things that maybe it would have made it a little simpler if we would have known before we started, and so I could put them in this video for you guys. One of the first things that really confused us about having both x and y in the problem is we didn't know what we were trying to solve for. But in this problem, you're not trying to solve for either x or y. The first thing that you have to realize is the derivative of y is going to be a little different than x, because when you have both in a problem, you can't know both derivatives. So what you're actually trying to find is what your derivative of y is. But since you can't do that, we have to use it as a variable. So the variable that we use to stand in for the derivative of y is dy dx. So whenever you start to derive and you need to put something as the derivative, that's what's going to stand in as your derivative so that you can solve for it. So I'm just going to walk you through an example and just kind of go through the things that confuse us. For your first one here, you have x squared y. That's obviously being multiplied together, so you're going to have to use the product rule. First times the derivative of your second. Now remember, the derivative of y is going to be dy dx. And then plus your second, which is y, times the derivative of your first. The derivative of x squared is 2x. Then you're going to go on to this one and derive it. Now this is just, you would do this the same as you would do any other. So you bring this in front and multiply, so you have 4, and you take one away, so you have y. But you still have to include dy dx. A lot of times whenever we do this, people think that your y automatically goes away and that stands in place for it, but that's not the case. Whenever you have any kind of variable up here, you derive this just as you would derive anything else. You just have to add in your dy dx. The reason that your y goes away here is because your variable here is 1. Whenever you take 1 away, that makes it 0. Anything to the power of 0 is 1. So you have a 1 right here, which we don't always write. You guys know that by now. So don't be mistaken, because many of us were mistaken. We thought that you would have to do y in all places, or that y would go away at all times. Either one of those can be really bad mistakes that you can make and get you confused. Then you have to go on and do your derivative of 5. Everybody, you guys already know that the derivative of a constant is 0. This was also a place that would get us mixed up a lot. We would assume that you automatically had to move it and try to set it equal to 0. You don't have to do that. A lot of times it'll work out that way for you, that it'll be equal to 0, but you won't have to move anything around in an implicit differentiation problem. Now here's where it really comes in handy to remember that dy dx is your variable. You're not trying to solve for y. You're not trying to solve for x. So you're trying to get dy dx by itself. You have it right here with your x squared, and you have it right here with your 4y. So what we're going to do is we're going to take away this, since it doesn't have a dy dx with it. We're going to move it to the other side. So you're going to end up with a negative y 2x. And that leaves you with an x squared dy dx plus a 4y dy dx. Now this is a really common mistake for us. Whenever Grace first showed us this problem, we couldn't figure out this part at all. We spent a lot of time trying to figure out until she finally had to tell us. A lot of times we always forget factoring never goes away in calculus. So here's what you have to do whenever you're trying to get your dy dx by yourself. Oftentimes you're going to find it with separate ones, and you think, well, how am I going to solve for 2 different variables? Well, you're not. You just have to factor this out. So when you take out your dy dx from here, you're left with an x squared. When you take out your dy dx here, you're left with a 4y equals, just bring down your negative y 2x. And now you have your dy dx factored out, but you still have this with it being multiplied So you're just going to divide this by both sides. And then you're going to end up with your dy dx down here by itself, the variable that you were trying to solve for. And now you know what your derivative of y is. And that's implicit differentiation. Just remember, there's a lot of points where you can mess up. Remember, you don't have to solve for 0. Also remember, y doesn't go away, but it also doesn't stay there every single time. You do your y just as you would do any other derivative. You just have to add in your dy dx, because your objective in these problems is to find what your derivative of y is. So you have to derive it just as you would any other thing, but you just have to add it in. And remember, calculus is never going to, factoring is never going to go away in calculus. Do not forget to factor out your dy dx. We've went over this again before testing to just refresh, and every one of us forgot factoring. That's the biggest thing on here. If you can remember that, implicit will be fine.